Hello everyone, welcome back to Abdo channel. In today's video, we will talk about the Lambda expressions that are introduced in Java version 8. So, why the Lambda expressions are introduced? What is the purpose of the Lambda expressions? What are the features of the Lambda expressions that we will discuss in this video? Basically, Lambda expressions are introduced in Java 8 to enable the functional programming concepts in Java programming language. Since many years, we have seen that Java is object-oriented programming language. Everything we write or we think, whenever we design or develop anything in Java programming language, we always think or design around the classes, objects, nouns, verbs, and all, right? So, um, but there is a concept, another programming paradigm, functional programming paradigm, that has been introduced to enable Java as a functional programming as well. Because with the programming, object-oriented programming system, we have written so many lines of code and we have written so many applications, right? But functional programming enables us to write more readable and more maintainable code and also more precise code. Okay. Suppose if we are having a method with having some 5-10 lines of code, we can evaluate, we can replace that with a 1 or 2 liners of the Lambda expressions. So we can write more precise code as well. Also, we can pass the functions as a argument to another functions. That is the another feature of the functional programming. They always revolve around the functions. Function code or the block of code itself will be passed as an argument to a function in functional programming. That also is coming up as a new feature with Lambda expressions in Java. So that is about the features and what are the different features that are coming to Java programming language with the advent of Lambda expressions, with the introduction of Lambda expressions into Java. Okay, now let's take a small example how to pass a function or how to pass a behavior as an argument to another function. Okay, let's write a small example. Once after that, we will see how to convert that example into by using Lambda expressions. Okay, say for example, I have a class. uh, I have a class line. Okay, so this line class is having a method eat. Okay, and we are just printing the eat action behavior. Line is eating something. Okay, I have another class. Okay, let me not put it as public class. I have another class tiger. Okay, that is also having a method public eat, public void eat. See, and this tiger is eat behavior is also same. Tiger is eating. Okay, so these are the two classes I have. Now I have my test class like animal test, and this is having a main function, main method, and here I am instantiating the lion object. I'm calling it. See, this is a simple class. Okay, let me rename it. and I have to instantiate line object here. Okay, now if you see this, this is a simple class having lion and tiger classes, and I am calling eat method on the line. Okay, if I run this program now, see it is printing lion, right? Lion is eating. But if I have to call the tiger class eat method, I have to change this program, this client program. I have to create an instance of the tiger class and call the eat method on the tiger, right? So, in order to avoid this problem, now this will print tiger is eating. So in order to avoid this problem, we have the concept of interfaces, right? So interfaces means it provides the dynamic polymorphism. You can create an instance of the implementation class of that interface dynamically. That particular instance method will be called, right? So let's create an interface now as animal. So, and this is having a method public void eat. The moment I have to implement from this animal interface, so every method, this line class has to implement the methods in the animal. So we have it already implemented. Here tiger class is also implementing from animal. So tiger is also overriding the method for eat. Now in this case, what we can do, we don't have to create that lion or tiger reference. We just provide the tiger or lion instance to the animal reference. So that way it will call whatever the object you are assigning, that particular instance method will be called. If you see this, see tiger is eating. If I pass lion, you can see the lion method getting executed. Okay. Now suppose I have a method here. Okay, public void eat action. In my client class, I have a method that takes lion. Okay, okay. Lion dot. This will call a method on the whatever the object we are passing, right? See, this is basically we are passing a reference here, and based on that reference, it is calling that particular method in that particular instance, in that particular reference. Okay. Now, if I call, let me comment this uh, animal test is equal to new animal test dot eat action of new lion. If I pass new lion, what will happen? We will see. Lion is eating. Basically, to this method we are passing the object, and based on that object, it is calling the method. If I have to call the tiger object, I have to pass the tiger, and I have to change this tiger as well. Right now it will execute the method that is available in the tiger class. So in order to avoid all these modifications, so we can have the interface here itself. Okay, so whatever the runtime instance that is injected dynamically into that animal, that will be executed. Okay, now if you see this test.eat action, we have to pass the animal instance or the implementation class of the animal, right? If you run this, lion is eating. If you assign tiger, tiger is eating. Okay, so this is one way we are not exactly passing the method or a block of code to another class like this. Okay, to this method. Okay, but this is a way of achieving passing or passing a method behavior or a behavior to a method. Here this is achieved by passing a reference or an interface or an implementation class to the method. Once it receives that reference, it will be calling the methods that are available on that reference or on that instance. Okay, so this is a way we achieve passing methods or behaviors to a method in object oriented programming system. Okay, now how can we convert this program to pass only the method behavior? Okay, what is the method or the behavior or the block of code? This is the block of code that is getting executed, right? So how can we pass this behavior rather than the reference using the lambda expression? That we will see it now. Okay, so what is the behavior we want to pass? This is the behavior we want to pass, right? So to whom we need to pass? We need to pass that behavior to eat action method. So earlier we are passing the animal reference, right? Let me comment that. Okay, now test dot eat action. Okay, this will take animal reference. Okay, we will see that. Now this is my method, right? Public void eat, and this is the method that is available in lion interface, lion implementation class, or the animal interface, or the tiger implementation class. So I want to provide the implementation of this animal interface. So animal. Okay, so whatever this is the method definition, right? So I am assigning the method definition to a variable here. This is similar to a variable of type string is holding the string variable, string data, right? Similarly, double variable holding the double value. Similarly, this method is being stored in this reference. Okay, whatever the method that is given here, that will be referred by this animal variable. So I can pass this animal variable directly here. Okay, so that is okay, but there is a problem here, right? Public void eat method, it is giving some errors here. So why those errors are coming? Because public void and eat, they are, I mean, public is referred to a method or a class, to a method when it is available inside a class, right? So but these lambda expressions are not specific to a or belonging to any class. So right, so we don't need to mention any access specifier. Okay, they are specifically relying outside or the outside of the class. Okay, now we don't even have to specify the return type. Okay, now we have the method name. Here we are storing already the type or the block of code into a variable. That variable we are giving a name, right? So we don't have to give the method name as well. Okay, now we have the arguments here. So we have the method definition also here. This method definition is not accepting any arguments, so we are giving it as empty parenthesis. So here we have to mention the bracket, not the bracket, arrow symbol like this. Okay, so this is the method definition that gets executed when there are no arguments passed to that method, and this will be stored in the animal type. Okay, now there is some error, we will see that. Duplicate local variable. Okay, let me comment this. Okay, now if you see this is the method exactly similar to your method that is available in the implementation class, and we are storing that method definition into a variable, and that variable we are passing to the eat action method. So we are directly passing the method definition or the behavior to a method by using the lambda expression. If you run it now, let's see how it goes. See this, whatever the implementation you are providing in that method, right? The method behavior that is being executed. Suppose if I want to run this. If I want to execute the tiger is eating or the tiger method behavior, then you can simply modify that. Okay, this way what will happen if your interface is having only one method, right? Then you don't even have to create the classes like this. If that class is being used at only one place, suppose if the class eat method you have to call it in multiple places, then you can create the implementation class implements from the animal interface. But here in this case I'm not going to use my implementation classes of this animal interface more than one place, so I will be providing that implementation here itself. Okay, this is exactly similar to like this. Okay, animal is equal to new lion or new animal. Okay, not lion, animal. So here we have to provide the definition of the method that is available in that interface. Okay, what is that method available? We have to override that method, right? Public void eat. So system dot out dot println of tiger is eating. So even if you comment this, see this now, okay, we have the animal reference, right? See, this is a anonymous inner class type of implementation to your interface. If you don't want to use your implementation class of your an animal interface, then you can provide the implementation then and there itself, that without any name given to that class. Okay, here this is actually an implementation, right? So here it is, when it is implementing the animal interface, we have to override that method and that is getting executed, right? Similarly, uh, this is, I mean, yeah, let me comment this. This is exactly the lambda expression which we have written, exactly similar to that. Okay, if you see this part of the code is being removed when you write the lambda expression, because we are not going to create any separate class for this one, and we are going to override whatever that is there in the animal interface. Okay, so this is the way we pass method behavior to another function using the lambda expression. That way we also reduced the number of lines of code, because earlier in the object oriented programming system in Java, before Java 8, we have to write the implementation classes like this, or either we have to provide the implementation like this, right, by using the anonymous inner class. All this is being uh, avoided and with just one line of code. That way we are writing the more precise code and the more readable and the maintainable code as well. Okay, suppose if you don't want to create even the reference like this, if you don't want to store a method or the block of code like this into a variable, you can directly give it. Okay, this expression itself you can directly pass it as a method. Okay, like this. Then let me comment this. What is the problem here? We'll see that. Test.eatAction animal in the type animal test is not applicable for arguments com.app.animal. Test.eatAction takes animal reference. Okay, This one I have to mention. Okay, here I have to remove this. Yep. Now see this. Here to test.eat action, we have to pass the animal method implementation class and the method that is available, right? So method that is available in the animal interface, that method behavior we are passing directly to this method. Okay, so that is the main feature of passing method as an argument, or the block of code as an argument to another function, that is enabled to Java using the Lambda expressions. Okay, so also this is also quite similar to the anonymous inner classes. I mean, there are some differences between anonymous inner class and Lambda expression, but almost similar to the anonymous inner class, the way it is implementing the Lambda expression here. Also, if you look at the classes that are generated in all these three approaches, there are some differences. Okay, let's say let me enable this one. Let me uncomment this. Okay, now I'll pass this and I will comment this one as well, and I'll open up this. Okay, now if you see this, okay, this is the object oriented way of passing the method behavior, right, by using the runtime polymorphism approach. Now if you see this is getting printed, that's okay. But if you see the generated classes here, right, animal test, this is our interface, this is the implementation classes, this is the test class or the client class. So four classes we are generating it when we use the approach of dynamic polymorphism to pass the method behavior as an argument to another function. Suppose if I use the anonymous inner class approach, what will happen? We will see that. Okay, this is the animal interface. We are assigning tiger. Okay, now, okay, let me comment that. Let me comment this line as well. Let me uncomment this. Okay, this is the anonymous inner class approach, right? Now here I am not writing any classes. Okay, I'm just having the interface and I'm using the anonymous inner class approach to override the method that is available in that interface. Okay, now if you see that public void it, okay, let me call this. See, this is okay, fine, right? But if you see the classes generation technique, see, this is my interface and this is my client class and this is the inner class. Okay, so one additional class is being generated, even though lion and tiger we are not writing the implementation classes. This is the anonymous inner class. Okay, now if you comment out everything and enable only the this one lambda expression, then we will see what happens. Okay, now let me run it. Okay, fine, the class is getting executed by using even the lambda expression, even though you don't have the implementation, because we are providing the implementation of that method that is available in the interface by using the lambda expression. Okay, now if you see, there is no anonymous inner class as well. Okay, that additional class file that is getting generated, that also being avoided if you use the lambda expression. Okay, but here we are not specifying any return type, right? We are not specifying any method name, we are not specifying any arguments, we are not specifying any return type, everything, right? But how is that this method is getting executed, right? That is because of this. Okay, suppose if you are passing a method like this, and it will try to check whether the interface, whether any particular interface is having the method signature exactly like this. See this, let me open up this one. Okay, let me pass this animal here. Okay, now what happens here, this is the method behavior we are passing to eat action, and this behavior is not accepting any arguments, but its type is we are mentioning here, right? This method's type is we are mentioning here, animal. So it goes to that particular interface and checks whether any other whether any method available which is exactly matching the signature with the one that we are passing here. Here we are passing a behavior which is not accepting anything and we are not returning anything, right? So there is a method available eat, okay, and this is not accepting anything and this is not returning anything. So the types are inferred here. Okay, basically even if you have any data types to that method, you don't have to mention the data types here. You can simply uh, put them here, okay, like this. Suppose see this int a comma b. Okay, this is the method signature. Now I can pass it here. Okay, animal dot eat sum 3 comma 4. Okay, so I'll pass 3 comma 4. So this one here, this method is also provided with some type of arguments, but while implementing that method using the lambda expression, we are not mentioning any types of those variables of those arguments. Okay, the types are also the type of input arguments, the type of return data, and also the method that it has to execute. All those are being compared or inferred from the interface, which is a type of that lambda expression. So for any lambda expression you are writing, there should be a method that is available in an interface. Okay, whether it is an out of the box interface or whether you are writing your own interface, that should there should be a matching method and an interface should be available in that matching to that lambda expression. Okay, say for example this is my another method in the same. Okay, suppose walk. Okay, this is another example in the same interface, public void walk. Okay, if you go there, what happens, the target type of this expression must be a functional interface. So this is driving us to know more details about the functional interface now. Okay, because whenever its type is being checked with an interface, that interface should be having only one abstract method. Okay, that interface should be having only one abstract method, but this interface is having two abstract methods. That's why it is not able to match your lambda expression signature with your method signature that is available in the interface. So functional interface is an interface that is having only one abstract method. It can have any other methods, static methods, any number of static methods, any number of default methods, but it should be having only one abstract method that will be used to match with your regular expression. Okay, okay, that's all for today. In the next video we will talk about the different examples which we by providing the object oriented approach, and also how we can convert that method based object oriented approach into the functional programming approach using the lambda expression. We will see the differences between those two approaches with some detailed examples as well. Okay.